evening, students. Welcome back to your chemistry class. In the last video we had studied about the discovery of electrons, and today we are going to talk about the discovery of protons and neutrons. Okay, so in this chapter of atomic structure, as I said last time, we had studied the discovery of electrons, right? And also the scientists knew that atoms are electrically neutral. So what does it mean that atoms are electrically neutral? That is, total positive charge is equal to total negative charge, isn't it? That is, total number of protons, are equal to total number of electrons. Therefore, it was said that atoms are electrically neutral. Okay, so now neutral. Thus, now we knew that the negative charges, that is the electrons, were already discovered. So if electrons are there, that means protons are also present in the atom. This led to the discovery of protons, is what we are going to study today. Discovery of protons. Okay, who discovered protons? Goldstein discovered protons, right? He noticed, now look at the figure, he noticed that set of rays traveling in a direction opposite to that of the cathode rays. Okay, that is from the anode towards cathode, when a perforated cathode was used in the discharge tube. He called these rays as canal rays. Why did he call these as canal rays? Because these rays, they pass through holes, or they are also termed as canals in the cathode, and these rays were named as positive rays or canal rays or anode rays. Clear? So discovery of proton is very clear. Now coming to the properties of anode rays. Anode rays, they travel in a straight line. They consist of minute material particles, and hence they produce mechanical effects. They are made up of positively charged particles. Positive rays, they are deflected by electric and magnetic fields, but in the direction opposite to that of the cathode rays. This means what? That these rays, they consist of positively charged particles called as protons. These rays, they produce fluorescence on the zinc sulfide screen. Then the E by M charge, that is, or we can say the ratio between the charge to the mass, it differs from gas to gas. Its value is much less than that of an electron, and it is maximum when hydrogen is taken in the discharge tube. Okay, then let's talk about the properties of protons. A proton, it possesses unit positive charge of +1. Its value is 1.602 into 10 to the power minus 19 coulombs. Its mass is the same as that of hydrogen, that is 1 AMU. Then the proton resides where? In the central part of the atom, where? In the nucleus. After all this discovery of electrons and protons, J.J. Thomson, he proposed the structure of an atom, and he called it as Plum pudding, the model of J.J. Thomson for an atom. So according to this model, an atom, it is considered to be a sphere of uniform positive charge, and electrons are embedded in it. The total positive charge, it is equal to the total negative charge, so that an atom as a whole is electrically neutral. Thus, the mass of an atom was considered to be uniformly distributed. Okay, after this came the discovery of nucleus. Now, in the discovery, who discovered nucleus? Rutherford. He was a scientist who directed stream of alpha particles. Now, what are alpha particles? These are positively charged particles, or what you say, helium particles, towards a very thin gold foil. Okay, he selected a gold foil because he wanted as thin of layer as possible, and gold was the most malleable metal for that. And what did he observe over here? If you look at the figure, most of the alpha particles, they pass straight through the foil. Some of the alpha particles, they were slightly deflected from their straight path, and very few of them got deflected by very large angles, and they bounced back. Thus, what did Rutherford conclude? He concluded that the atom, it consists of large empty space. That is why most of the alpha particles, they pass through the metal foil without deviating from their path. Then there was a positively charged mass at the center of the atom, which is known as nucleus, in which the entire mass of the atom is concentrated. Therefore, the nucleus is the densest of the atom. The electrically positive nature of this nucleus is supported by the fact that all the alpha particles approaching the nucleus, they got deflected over here. This proved that nucleus contained protons. Then let us now talk about the size of the nucleus. It is very small compared to the size of an atom. Just imagine the field of your school, right? And a small cork ball is placed in between the field. So that cork ball can be your nucleus, and the huge field is the complete atom. So this is proved how that most of the alpha particles, they were passing straight through the gold foil. The electrons, now where are the electrons found in the atom? So electrons, they revolve around the nucleus at large distances from each other and from the nucleus. An atom as a whole is electrically neutral. Why? We already know, because total positive charge is equal to total negative charge. And these electrons, they always revolve around the nucleus on the orbits. The force of attraction between the negatively charged electrons and the positively charged nucleus, it is counterbalanced by the centrifugal force acquired by the revolving electrons. Rutherford's model of atomic structure, it was very similar to that of the solar system. Just as in the solar system we have a sun in the center, right? Similarly, over here in the atom we have the nucleus in the center. Then you have the orbits on which the planets are revolving around. Similarly, in this structure of an atom, we have the electrons which are revolving around on the shells or the orbits. Is this clear to all of you? Now, there was some drawback in the Rutherford's atomic model. This model was termed as atomic model, but there were certain drawbacks. The comparison of the electrons with the planet in the solar system, this was the main drawback of the Rutherford's atomic model. According to the classical laws of dynamics, if an electrically charged particle is in continuous motion, then it is going to radiate energy. In the same manner, if you are asked to run on the tracks of your field, then a time will come when you are going to radiate energy, you will lose energy. Thus, when the electron, it loses energy while moving around the nucleus, it is pulled towards the nucleus and ends up colliding with it. So this results in the total collapse of the atom. If it is so, if this would have happened so, then the atom should be highly unstable, and hence there would have been no matter that would exist in the form that we know. However, we know that atom is structurally stable, and therefore Rutherford's model was also discarded because it did not explain the stability of an atom. Now, the scientists started working on the stability of this atom. So, Niels Bohr, a Danish physicist, he explained the causes of the stability of the atom in the different manner. What were his postulates? According to Bohr, the electrons, they revolve around in the nucleus confined to a certain fixed orbit. And what are those orbits called as? Shells, or they are also termed as energy levels, each of which is associated with a fixed amount of energy. Now, while it is revolving around the nucleus in an orbit, an electron neither loses nor gains any energy. So, an electron revolving in a particular orbit, on gaining a certain amount of energy, will, after it gains a certain amount of energy, it will only jump to the next orbit. Till it does not attain that energy which is fixed for that particular orbit, it cannot jump to the next one. Now, when after revolving for a certain time, again when it acquires the complete energy, then only it can move to the next orbit. Now, since each orbit, it is associated with a fixed amount of energy, as I told you, therefore these shells or these orbits, they are also called as energy level, and Bohr called it as energy level. Why? Again I repeat, because each orbit was now associated with fixed amount of energy. Till these electrons, while revolving round that orbit or that shell, did not complete that fixed amount of energy, they were not able to jump to the next shell, and hence this explained the stability of the atom. And for convenience, what did Bohr do? He labeled all these shells as K, L, M, N and so on. The orbit which was closest to the nucleus, he termed it as K. Look at the figure, you will understand. It has the least amount of energy, and the electrons present in it, they are termed as K electrons. Then it moves to the next shell, that is L orbit, and their electrons, and so on. So this was the Bohr's atomic model. Now came the discovery of neutrons. By now the scientists were very happy that they had already discovered the fundamental particles of the atom. Okay, but suddenly when an atom of helium was noticed, it contained 2 protons, right? That means mass should have been equal to 2 AMU. But the atomic mass of helium was actually found to be approximately 4 AMU. So therefore, this led to the discovery of neutrons. How? That the protons are 2 and electrons had no mass. That means the atomic mass of helium should have been 2. But no, it was found approximately how much? 4 AMU. That means there is another particle in this atom which has the mass of 2 AMU. 2 AMU means the mass of this particular new particle should be equal to the mass of the proton. But this new particle should not have any sign of it. Why? Because atom is electrically neutral, and number of protons and number of electrons, they were already discovered. So this particular particle should not contain any charge over it, any sign over it, plus the mass of it should be equal to that of what? Protons. And what did I say in the beginning? That the mass of helium was found to be 4 AMU. That means where should this new particle be found in? It should be found in the nucleus. Why? Because actual mass of the atom is found in the nucleus. Clear? So this all led to the discovery of neutron. Now, Chadwick, he discovered these particles by bombarding light nuclei like beryllium with the alpha particles, and he obtained neutrons, and thus these particles were found to be neutral and they had no charge over them, and they were called as neutrons, and they are found in the nucleus of an atom. Let us talk about the properties. This particle was not found to be deflected by any magnetic or electric field, proving that it was electrically neutral, and its mass was equal to 1.676 into 10 to the minus 24 grams, that is 1 AMU. somewhat equivalent to the mass of proton. So we stop over here after understanding the complete structure of an atom, that is, after the discovery of electrons, protons and neutrons, which were the subparticles, it was found that all the atoms, they have the following basic structure. What? That electrons are negatively charged and they are found outside the nucleus, revolving around the nucleus. Protons are positively charged particles, they are found in the nucleus, and neutrons are electrically neutral particles and they are also found in the nucleus, right? And neutrons were very slightly heavier than protons, but approximately they were equivalent. With this, I wind up today. Thank you.